dreams, do you have any
Ah,
insights on dreams and what they might be doing and to what degree they're adaptive?
um, so dreaming is a really interesting situation in which your natural neuromodulators, your natural psychedelics, as it were, are switched off to the extent that you're now sequestering the brain from all of its sensory inputs, with the exception of the central nervous system, which is the eyes and the oculomotor system. Um, so what that means is when you're asleep, there is no sensory information to make any sense of, with the exception of the eyes, which is why you have rapid eye movement during dreaming. So how can you minimize the free energy when there is no data to explain or to predict? Um, and the answer to that, I think, is quite profound. It's a bit mathematical, but I think it's worthwhile just mentioning it, because it provides, I think, a really useful perspective on sleep, on introspection, on aha moments, on creativity, and that perspective is afforded by realizing that surprise is the same thing, or can always be written as complexity minus accuracy, whereby what I mean by complexity and accuracy is that the accuracy is the um, effectively the how accurate your predictions are, which is one way of understanding the role of prediction errors as scoring the surprise. So the more accurate your predictions, the smaller your prediction errors. But there's also a complexity part of surprise, as described by the variational free energy. And that complexity scores the degree or the degrees of freedom you've had to use up in order to provide that accurate account. It literally scores the degree to which you change your mind in order to explain this pattern of sensory input, or this bit of data. So if you want to minimize surprise, you want to maximize accuracy while minimizing complexity. What does minimizing complexity entail? It means finding the simplest explanation for some data possible. It's just Occam's principle. In the words of Einstein, keep everything as simple as possible, but no simpler. So there's a sweet spot that gives you an accurate explanation that is as simple or minimally complex as possible. So you can still, in the absence of data, so in the absence of any data, there is no accuracy. So surprise just is complexity. So if you want to minimize surprise while you're asleep, you minimize complexity. What does that mean? It just means removing redundant degrees of freedom from your generative model. It just means house cleaning, removing redundant synaptic connections. People like Julia Tononi would regard this as synaptic homeostasis from a biological point of view. It's basically minimizing the complexity of your world models by asking, could I have explained this particular dream more simply? And were these two associations in fact the same thing? So this is why I mentioned sort of aha moments and the creativity that comes from the insight that all of these different things are in fact examples of the same thing. And that just means basically pruning away exuberant, incidental synaptic connections, brain connections that are not necessary just to get at the underlying scaffold, the basic structure of your generative model. So in that sense, whenever you introspect, whenever you have an aha moment, you are basically suddenly seeing the wood from the trees. You're suddenly seeing the big picture, the simple picture, by identifying what is important and what was a distraction, and then literally getting a much simpler, more coherent, minimally complex explanation of what's going on. And that's a really important mechanism to minimize surprise or minimize free energy, to get these good generative models that will, from the point of view of sleep, mean that your model will generalize to tomorrow.